now that we have reviewed a little bit on some steps and calculator, we're ready to start the actual lesson. And in this lesson, we're talking about matrix inverses. To understand some things, we're going to review some properties of mathematics. And the first one is the identity property of multiplication. And multiplication is commutative. So it says 1 times any number is equal to the same number times 1, which is equal to A. So if I have 4 times 1, I know the product is 4. If I have 1 times 4, the product is also 4. So that's the identity property of multiplication. So this next one is the one we're going to be talking about. In matrices, we're going to be discussing inverses of a matrix. In mathematics, we talk about reciprocal, or the flip of the fraction, which gives us a 1. And that 1 means that we have an identity of what makes the product 1. And that's what this inverse study is going to be. Now, I typed a lot of these notes to make sure I don't omit anything for you. In this lesson, we will understand the similarities of these concepts as they apply to a matrix. To begin, there are some criteria for the identity matrix I. The constructed matrix in the question, which is matrix A, has to be a square matrix. So we have A and I. And matrix A is a square, a 3 by 3, a 2 by 2, or a 4 by 4. The identity matrix has 1s and 0s in a pattern where the 1s occur diagonally in the matrix surrounded with 0s. So we can see from this is a 2 by 2, the diagonal is there. I should use a different color, shouldn't I? Let's do this one. And in a 3 by 3, we can see the 1s are diagonals surrounded by 0s, and that's an identity matrix. So we're going to do an example so we totally understand that identity property of multiplication. We said earlier that A times 1 is A, and 1 times A is also A. And remember, identity equals 1. Okay, so let's see what we can do here. And we're going to do it first by multiplication in one fashion, and then we'll do it in the reverse. All right, so we're going to first say matrix A times identity, and both are a square matrix. So we have a 1, a 3, a 2, and a 5. Here's my matrix A. And then we're going to multiply that by our identity. It's a 2 by 2 as well. 1, 0, 0, 1. All right. So let's see what we have. If I'm doing row by column, then my first entry would be the 1 times the 1 plus 3 times a 0. All right, so now I'm going to do the second part of that, which is going to be a 1 times a 0 and a 3 times a 1. Then on my next row, it'll be a 2 times the 1 plus a 5 times a 0. And for the next row, it would be the 2 times the 0 and the 5 times the 1. All right, so right here we have the math of it. And we're going to see that this guy equals 1. this guy equals 3, this guy equals 2, and this guy equals 5. And the result is what we started with. Exactly. All right. Now we're going to do the reverse. And the identity matrix times the A. Here we go. So this time I have the 1, 0, 0, 1. That's my identity, a 2 by 2. And then I have the values 1 and 3, 2 and 5. Right. So I'm going to have this row times the column, 1 times 1 plus 0 times 2. All right. Then for the same row, I'm going to have the 3 and the 5. 1 times the 3 plus 0 times the 5. All right. Now I'm doing the second row, which is this one here. 0 times the 1 plus 1 times the 1. 2, sorry. Okay, now I'm doing the second row, second column. So here I'm going to have 0 times the 3 plus 1 times the 5. All right, so let's do, again, we're talking each of these little maths. So I have 1 plus 0 is 1. 3 plus 0 is 3. 2 plus 0 is 2. 0, and this is, oh, my plus didn't come out. All right. 0 plus 5 is 5. And we have reached the same item. All right. Now, do I expect you to do that? No. I don't expect you to put in the calculator and figure out these examples. Okay. So we're now going to have reciprocals of a matrix, reciprocals of a matrix, and how to construct one. So we'll be using the TI-84, but we want to know what they're saying about it. So the notation is, this is my original matrix. And if I have a inverse, well, that is my what? Oh, an inverse matrix. All right. So it says to obtain an inverse matrix, you're multiplying for any n A by A, meaning square matrix. Following steps have to take place. You have a matrix, an augmented form, times the identity matrix. And then it says perform the operations, which we know as echelon method. To convert I and A inverse, because that's what will happen. We make the A matrix into I's, 1, 0, 0, 1, or however many the square matrix are. And then it creates on the opposite side where the identity matrix is into the inverse. All right. On I, 84, we have the following information. You may pause this and write these steps down, but I'm going to identify, making sure I haven't made some form of entry error or typing error more than likely. To enter a matrix into a calculator, we've done this 100 times, it seems like. It's second inverse inverse sign of X, and which above it is matrix, to a new window on the home screen. You arrow over, and I'll make that a filled in arrow. So there you go. We'll arrow over to edit a heading, the edit heading. Select one and enter. Insert using number pad row by columns of a square matrix A. Enter each row value using enter to advance. Okay, so we've done that. It has to be a square matrix and it has to be entered accurately. The second part are steps for finding inverse A of the matrix A. So we're going to again hit second matrix to the window that says names, highlighted, and enter matrix A to the home screen. Next, click the inverse key. This is called the inverse key. We hit the inverse key without the second. We just need the actual key, and enter and read the inverse matrix. If there is a row of all zeros, then an inverse is not possible, and the calculator will read error. Okay, that means there's no inverse to that item, and we're going to have an example to prove that point. Okay. You can hit pause now and copy if need be. Let's move on to an example. And we're going to do this example by hand because we want to learn the process just in case. So here we go. So I have this matrix and I'm going to first convert to an augmented matrix of A identity on the side, both square. So I'm going to do the 2, 2, 2, 5 there, and I'm going to put my identity 1, 0, 0, 1. All right. So this is our augmented matrix, and we're going to make the 2's. Well, let's just do this first. We're going to say row 2 minus row 1 gives us a new row 2. Okay, so this means I'm going to have a 2, 5, 0, 1. And I'm going to subtract, I'm going to change all signs to that first line. -2, -2, -1, and 0. When I do this, this is my new row 2. Well, this is 0, this is a 3, this is a -1 and a 1. All right, so I'm going to rewrite the matrix with the condition of what I just did. 2, 2, 1, 0, and I'm going to have 0, 3, -1, and 1. All right. Okay. So what I want to do now is remove this 2. And I could possibly go ahead and divide everything, but I get a fraction. So what I'm going to do is an LCM. So I'm going to, let's see, I'm going to take row 2, and I'm going to do 2 of them because I need a 6. Row 2's minus 3 row 1's. Or I should do it the reverse, right? 2 is 6. Right, if I'm doing 2 here, I get 6. Yeah. Okay. All right. I'll do that. Now, let's do it correct. Let's do 3 row 1s minus 2 row 2s to get a new row 1. All right. So I'm going to have 3 parentheses on the 2, 2, 1, 0. And on the other line, I'm going to have a -2 to the 0, 3, -1, and 1. All right. Sometimes a little math is what gets us, right? It doesn't come out right. 6, 6, 3, 0. Right here, I'm going to have 0, -6, and I'm going to have a +2 and a -2, right? -6, +2, -2. All right. I'm going to have 6, 0, 5, and -2. Okay. All right then. I'm going to write that in. 6, 0, 5, -2. That's my new row 1. And I had 0, 3, -1, and 1. All right. So I'm going to do divide by 6 on that one and divide by 3 to get that identity matrix. So I'm going to have a 1, 0, 5 6s, a -2 6, 0, 1, a -1/3, and a +1/3. All right. Well, this guy right here needs to be reduced. So I'm going to have 1, 0, 0, 1, and I'm going to get the 5 6, a -1/3, a -1/3, and a 1/3. All right. So my A inverse is that second part. Okay, not hard, but we're going to be doing everything by calculator. And all you have to do is input well, and then we're going to hit math frac. All right. But I wanted to do this one by hand because it was easy and you could see all of the steps. So here we get to this one. Find the inverse if it exists. Well, I can tell you right now that I'm going to structure it because this way you understand, and we're going to do this one on a calculator. All right. So I'm going to say row 1 minus row 2 for the new row 1. Okay. Well, mine is a -3, -6, a 1, and a 0. And if I do this by a negative, I'm going to have a +3, a +6, okay, a 0, and a -1. All right. So what do I get? 0, 0, 1, -1. This can't happen. So this has no inverse possible. These guys are the same, and they throw out each other, so it's pointless. So let's talk about how does it look like doing the calculator. Here we go. I'm going to go clear this second matrix. I'm going to go to edit. It is a 2 by 2. Oh, there we go. All right. So I'm going to enter a -3, -6, 3, -6. All right. I have them all correct. All right. So I'm going to name it second matrix. Name it. And I'm going to hit the inverse key. Same key that I do with the second. And enter. And it says error. Does everybody see? it says error on singular matrix because it has no inverse. No inverse. Read it right there. No inverse matrix exists. All right. There you have it. So now you've seen it on both things. All right. All righty. I gave it too many commands. There we go. All right. So we're going to find this one. First, we have to prove that it's a square matrix. All righty. So I have row 1, row 2, row 3. All right. Then I have column 1, column 2, column 3. So, yes, it is a 3 by 3. Okay. Second, we're going to enter to calculator. All right. So here we go. I have to turn it on. Is it thinking? Yeah, it's thinking. Sorry. Come on. No, it's not coming on. Oh, there it is. Sorry. I'm impatient. Okay, I'm going to start right here. I'm going to start on the next part. Thank you.